All right, so let me see if I can figure this out. Okay. All right. Here we go. Yeah, okay, this will work. Okay, so let's get out page 128. To show you the last of the formulas for the year. It's the last formula of the year. What's that? And it has to do with what we did yesterday. Okay. All right, location of image math. All right, does everybody have a protractor or a straight edge? You just need a ruler or a protractor. Does everybody have a protractor around you? Look around you. Pretty yucky. Let's draw a horizontal line right here at the top of this page. Okay, move this protractor. All right, now I want you to draw a quick concave lens sort of in the middle. You can rough it out. It does not have to be perfect. Just kind of sketch out a concave lens here. No, sorry, convex is what I meant to say. Whatever. Okay. Now, do you remember what also, let's put a dot sort of right in the middle. And then we're going to put a dot every 3 centimeters just to be consistent with what we did yesterday. Okay, so I'm doing, 3 centimeters and 3 centimeters. And then I'm going to go this direction. And I'm going to go 3 centimeters, 3 centimeters. Okay. I'm going to label this F. That's your focal point. And I'm going to put an object right here, kind of between F and C. So do you guys remember the first step when we draw a ray diagram? What do we do first? Yeah, do a dotted line and bisect the lens. Let me do it real quick. Okay. All right, now, first ray of light goes off the top and hits that center point of the lens. And then does it converge to the focal point or does it diverge out? Converge, yeah. Somebody told me a good way to remember it. The word convex has an X in it, and that means that the rays cross. Okay, and then the word concave has a B in it, which means it go out. B. Does that make sense? Maybe a good way to remember. Anyway, this is convex, so it's going to come together like this. Now, the second ray of light, if you remember, goes straight through the center. So straight through the center looks like this. You're going to go all the way down here so you can see where they cross and draw your image. So this is your image. Of course, this is your object. All right, so I'm going to give you a second. I'm going to ready to draw this. So I'm going to show you where all these variables are. All right. You're very good. No. All right. So now when we do the math, we're going to look at these distances. All right, this distance here from the center of the lens to F is called the focal length. Okay. The distance to from the center of the lens to the object, this distance here is called the D sub O, object distance. O is object, D is distance. Okay. Now, we can also look at what's called the height of the object, and that is HO. Okay, so let's go back through this. We have the length to the focal point, this focal length. We have the distance of the object, that's DO, and we have the height of the object, that's HO. All right, is everybody with? So we're just going to do the same thing for the image, okay? So this length here is the distance of the image, DI. And this height over here is HI. That's all. Those are the variables. So I'm going to give you a few formulas here. All right, so 1 over F equals 1 over DI plus 1 over DO. When you do this formula, you want to rely on your x to the -1 button. Because just like we did when we did parallel resistors, it makes it super easy. Okay, I'm going to show you how to do that. Okay, now, does anybody know what magnification means? If I say something's magnified, what does that mean? It's bigger. So magnification is how many times the object, you know, how many is kind of a, well, okay, magnification is like a factor by how much you're changing the height of the object, okay? So we also can find that magnification using these variables. And so here's how we do that. Magnification equals HI over HO, I-ho. All right, and we don't use this one quite as much as we use magnification equals negative DI over DO, dido. I heard dido. There we go. That's it. And ding, ding, ding. That's the last. This is the last formula of the semester. We're done. We need to know how to use them. So all right, so let's define these variables. Okay. F equals focal length. Can y'all see okay? Everybody good back there? What is it up here? You up here?
Yeah. She's a little behind.
You can come up afterwards, or I can put it back up there afterwards. Okay, yeah. You don't have to go off the picture. I just want to get through this so that we can, at the end, we'll have some minutes to go back through it. Okay, I just want to do a few examples. So F is focal length, okay? DI is image distance from the center of the lens. DO is what? Object distance. Go ahead and memorize this. I is image, O is object. Okay. HI, what is that? Image height. Good. And HO is object height. M is magnification. Okay, that seems like a lot, but it's really just a bunch of distances. And I'll say this too. These are very small distances. So in general, we are going to do these in centimeters, or sometimes it'll be in millimeters. It's okay if everything's in centimeters. You don't have to necessarily make them meters. Just make sure they all have the same unit. You know what I mean? All right, a few more things to write down, and then we're going to do an example. We'll wait. So a few more things to write down. If M is greater than 1, all right, it means that the object of the image is larger, or you might see the word magnified. If M is less than 1, then the image is smaller, or you might see the word reduced. A few things to just remember. Negative F implies is a concave lens. And a negative image distance is a virtual image. Which means it's yeah, so whatever. Okay. What do y'all think about that? Yes, sir. Yes, okay, so let's look at that real quick. The question is, what is a virtual image? For a lens, a virtual image is on the same side as the object. So so this DI here is positive, but if it's over here, then it's a negative number, okay? The other thing about a virtual image is you can always know it's a virtual image because the image is upright. A real image is upside down, okay? The third way you know it's virtual is if you had to use dotted lines to find it, okay? And then of course this is real because it's made with real lines of light, okay? Great question. Okay. Let's do a couple examples on page 129. Okay. Examples. Number 1. An object is placed ten centimeters from a concave lens. An image is formed at -3 centimeters. In other words, it's on the same side as the object. All right, we want to find focal length and magnification. So last period, they wanted to do just a rough drawing, just to kind of see what it looked like set up, okay? Which I don't think is a bad idea. We just don't have all of the placement to put everything. Like, we don't know where the focal length is. But we can do like a rough drawing just to see what the basic shape would look like, okay? So if I did like a, I'm doing this without a protractor. If I did a principal axis and I put a concave lens here, and, you know, I put an object, you know, this is 10 centimeters away. We know that you draw two lines of light. You know, of course, you're going to bisect this. I'm just freehanding this. We know that you would draw two rays of light coming off the top of that object from yesterday. We know this. Okay. So the first ray of light would be parallel. And then does it go out away, or does it go towards, like, does it converge, or does it come out? It goes out. Does everybody agree with that? So this concave lens is a diverging lens. So this goes out, you know, this way somewhere. Okay. And then the second ray of light goes straight through the center, you know, like that or whatever. Okay. So something like that. And in order to get this light to cross, you would just have to back this up, and you've got a little image right here and where these cross. And I'm given in the problem that that's 3 centimeters. This is what you're looking at. Okay, I know that's really tiny, super tiny. I put a little arrow right there. I backed this up, and I put an arrow right there. And that's 3 centimeters. I know that. I don't know where the focal point is though. So, is everybody good with this? Nolan, are you good? Does it make sense, kind of? I mean, this is sort of just a rough sketch.
Yeah.
This is rough. All right, so let's write our givens and let's just actually solve the problem. Okay. DO is what? Good, 10 centimeters. What is, what else do we know?
Wait, so did we just make that up? Oh, never.
DI is what? -3. F is my question mark, yes? So you're doing this little equation. 1 over F is 1 over di over 1 over dou. So I'm going to get 1 over -3 plus 1 over 10 equals 1 over F. And you've got to use the little extra -1 button. It makes it super duper easy. In other words, I'm going to write it out for you so you know how to do this. Okay? You're going to put in your calculator -3 x to the -1 plus 10 x to the -1 equals answer. And then you have to do x to the -1 of the answer. So what are we getting for our focal length? Yes. Excellent. What's your unit? Good. Here, let me show you how to put this in for those of you who still didn't catch that. So what we're going to do, -3. This is not -3 x to the -1 plus 10 x to the -1 equals. Once you get an answer, you have to take the reciprocal of that answer, and you get 4.29 centimeters. Negative 4.29. Negative 4.29 centimeters. Now, does it make sense that that's negative? Say again? I'm gonna scroll over. Look, F is negative for a concave lens because it's a virtual focal point. Okay, so we're good with that being negative. Now, let's really quickly, hey, everybody look at me and nod. Are y'all good with this? No. Where are we stuck? Broker, you good? Yes, absolutely. Okay. All right, so I'm gonna do this fraction is -3. I'm gonna hit x to the -1. That's basically 1 over -3. And you can put that into, you could do it like this. You could do 1 divided by -3. You could do it like that, plus 1 divided by 10. You can do it like that too. I just like the x to the -1 button. Does that make sense? All right, and then once you get that answer, you need to take the reciprocal of that answer. That's why I hit x to the -1 again. Okay. Yes. I just wrote it in the formula. I mean, I wrote it in the problem.
The DI is right there.
Wait a minute. What's your question? Wait. Do you see that I gave it to you in the problem, but also?
Yeah, I saw you gave it to me. I just didn't know that.
Oh, that's the image distance. All right, let's do magnification real quick. Magnification is negative di over dou. So that's -3 over 10. So what are we getting for magnification? Yeah, 0.3. Now, does that make sense? What does that mean? That is the image larger or smaller? Smaller by a third, actually. Like if you were the image, if you were the object, your image would be a third of the height of you. Okay, it's just smaller, which makes sense in our picture because we did draw a smaller image here. Okay, so what do y'all think about this? Okay, no big deal. All right, let's do one more example. Number 2. Let's do a convex lens. Okay, so a convex lens has a focal length of 15 centimeters. The image is formed at 32 centimeters. Find the object distance and the magnification of the magnification. Now, do we want to do a little rough sketch of this? We do. Okay, good. I kind of want to also. All right, so I'm just going to freehand a principal axis, and I'm going to draw a concave lens, sort of like this. And I'm going to put an object over here. I don't know how far this object is. It doesn't tell me. That's what I'm looking for. Now, the first thing that we do, as you know, is we're going to bisect this Lens, not, oh, the focal length. Oh, wait. We don't really know where the focal length is in relation to the object. We just really kind of don't have enough information, okay? But we can assume that there's an image like way out here. If this is 15, the image is like twice as far. Okay, so it's going to be upside down, it's going to be over here. Okay, so we're kind of doing a little bit of this, like it's going this way, and it's like zing, it's going like that. It's something like this. Is rough. Okay. But we do know that this is 32 centimeters. And we know that there's some focal point at 10 centimeters, or 15. 15, something like that. Anyway, whatever, it doesn't matter. I just want to kind of look at what the picture would look like. It might be easier to rough out a picture after you solve all this stuff. All right, so F is 15 centimeters. DI is 32 centimeters, and we're looking for DO. So we know that 1 over F, or let's see, is it 1 over F equals 1 over DI, 1 over DO. So I've got 1 over 15 equals 1 over 32 plus 1 over DO. You're going to use your same reciprocal buttons, if that makes sense to you. So it's basically 15 to the negative 1 minus 32 to the negative 1 equals DO to the negative 1. So what are we getting for the object distance? Yeah, 28.2. So you got? Y'all working ahead? Good. What do y'all think, people? Thomas, you good back there? Put on, you good back there? I am getting, if I put this in my calculator, 15 minus 32, I get negative 1 of that. No, put that wrong. 15 minus 32, 28.2. Centimeters. So in other words, this is 28.2 centimeters. You know, okay, that makes sense. Whatever. All right, let's talk about magnification. What is the magnification? You try calculate the magnification real quick. Oh, I did this wrong last year. No, I didn't. I did it right. I just did it wrong just now. This is not 15. It's 28.2. Oops. All right, 28.2. 1.13. Oh yeah, I did it right. All right, thoughts and feelings. What do you think about this? Anne, are you good? Good. Who else? Everybody okay? All right, I've got some practice problems for you. And that is all got. Yeah, wait, what do you want me to do? Zoom out? Zoom in to which one?
No, please go back to see exactly what you said.
This?
Yes.
So that?
Yeah.
Okay.
All right, thank you.
I mean, y'all can come up here and take pictures. All right, I'm gonna stop the recording.
think I just recorded that. I don't know.
Hi, Sasha.
Why are you laughing? Okay, I'm going to give you, here's my plan. I'm gonna give you some practice on a class of this and also Snell's law, like of all the math that we've done. Okay, what's so funny?
It was just, yeah, ask you like keep it there.
And I totally
Yeah.
So, that's what I'm thinking I'll do for practice for this. Does that make sense? There's also the packet. So there's practice in the packet. I think I have plenty of practice. And, right now, let's work on this. Because I know we're gonna finish. There's one weird one here that I want to look at with you. And it is number 5 on page 126. Okay, so I want you to look at that one, do the rules for number 5, and then I want you to see if you can figure out where that image is. Okay, so number 5 is a little different on page 126. Okay. Okay. All right, is everybody good? Are y'all good? Are we good to be done? All right, does everybody have this? Everybody has all of this.
Oh, so much teaching. Oh, this is still going. Oh gosh. How do I make this stop?